Welcome everyone. In this video lecture, we will solve a problem based on diode. Okay, and it is from the Microelectronics circuits book. So the question is, for the circuit shown below, the circuit is shown below. Okay, having two diodes, and this current I equals to 10 milliampere. Some resistance is there, and this voltage is V, and both the diodes are identical. Having two condition is given a diode conducting 10 milliampere. So the first condition is given, diode conducting 10 milliampere current at 0.7 volt, and another one is given 100 milliampere at 0.8 volt. Okay, so find the value of R. Okay, so we have to find the value of R for V equals to 80 millivolt. So this one is our V. Okay, so now here two conditions are given. Okay, so from these two conditions, there may be some missing parameter will be there. So first of all, what we have to do, what we can say, for now from this circuit, we can say I am saying this current is say I1, and this current is say I2. So I2 is nothing but simply 10 milliampere minus I1. Okay, clear this one? 10 milliampere minus I1. Okay, so these two current we have assumed. So now diode equation we can write for both are identical, na? So ID can be written as IS exp VD by eta VT, general diode equation. So eta is not known to us, eta is nothing given, so we have to take care. Okay, so ID value is 10 milliampere. So if this one is 10 milliampere, so one can write IS exp VD 0.7 by eta VT is also known to us, so one expression. And here also one can write 100 milliampere equals to identical diode, so the situation current will be same, 0.8 by eta VT. So both having IS value same, but eta may be different. So I am saying this one value is equation 1, equation 2. So if we divide, okay, equation 2 by 1, so what I am doing, 2 by 1. Why we are doing? Because first we are trying to find the identity vector. Because this is will be cancelled, but I eta will be there. So that eta we have to find, because this is not a simple question we can say, but the missing parameter we have to find. So 2 by 1. So it will give 100 milliampere by 10 milliampere. Okay. Then IS exp 0.8 by eta VT by IS exp 0.7 eta VT. So this cancel, it should be our simply 10. Okay, or this can be written as exp 0.8 minus 0.7, or I'm writing one more line, 0.7 eta VT, or exp 0.1 divided by eta VT. Okay, so one more line, exp eta VT. Okay, VT is known to us 25 millivolt, so we can write this as a 0.1 by eta VT is equal to ln 10. So now from here, what we can find the value of eta, because these two conditions are given to find the value of eta. So we have to, that's why we have used this two equation. So eta value can be written as 0.1 not 10 into VT. Okay, so what we can do, 0.1 ln 10 is nothing but simply 2.3025 like that. Okay, and VT 25 millivolt, so 0.025. VT 25 millivolt. Okay, it is given, or you have to remember. So if we solve this one, okay, it will come 1.737. Okay, so the eta value that we have first calculated. Okay, so these two condition is given to find out the value of eta. So now from these two condition it came 1.737. Okay, so now eta is now known to us. So now we have to find this V. So what we are doing, I am saying this voltage is a V2, and I am saying this voltage is a V1. Okay, across D1. And if we apply KVL in this loop by applying KVL in loop 1. Okay, so by applying KVL in loop 1, we can easily write plus V2, okay, minus V1 minus V equals to 0. So we can write V equals to V2 minus V1. So if we find the value of V2 minus V1, we can easily find the value of V. So this equation I am saying equation number 3. Okay. So now by using the diode equation for this one, we can say this one is a I2 current and this one is our I1 current. So first we are just starting with I1 current. Okay, so the I1 current can be written as IS exp V1 by eta Vt, simply our diode equation. Okay, so now from here one can write simply V1 equals to eta Vt ln ln I1 by Is. Okay, similarly the equation for I2, that is our this means 10 milliampere minus I1, means I am saying this I2 is somehow Is ex to the exp, say V2 by eta Vt, or V2 equals to eta Vt, simple equation. Now in terms of V1 minus V2, so we have to find V2 minus V1. So what we can do, we have to write for V2 minus V1. So one can easily write eta Vt. Okay, then this should be common in both. So I2 by Is, I1 by Is. Okay, this is a simple equation. Okay, now this can be also ln A minus ln B. Okay, ln A minus ln B. So it should be I2 by Is by I1 by Is, or eta Vt ln it should be I2 by I1. Okay, means this can be written as like this eta Vt. Now I2, I1, everything is known to us, and this V2 minus V1 is simply our V volt. Okay, from equation 3, and in your question it is given 80 millivolt. Okay, 80 millivolt. 80 millivolt is there, so we have to find the R. Okay, so this is clear, this equation. Now what we can do, okay, V2 minus V1. Now the value of eta is known to us, eta value we have calculated. Okay, one more line, I2 by I1 is there. Okay, and this one is our V. So now one more line, 1.737. I2 value is, what is the value of I2? We have to say I2 is this one, 10 milliampere minus I1. 10 milliampere, I1 is going, so it should be 10 milliampere minus I1. So I2 will be 10 milliampere means 0.01 minus I1. Okay, 10 milliampere. 10 into 10 to the power minus 3, 10 to the power minus 2 means 0.01. Okay, 0.01 minus I1, because this one is 10 milliampere. Here it is going I1, so here it is going 10 milliampere minus I1 in diode D2. In D2 it is going, in D1 this I1. Okay, simple. So and this would be simply our I1. So now from here we have to find I1, because this one is given also 80 millivolt. This V is given 80 millivolt. Okay. So now what we will do, V2 minus V1 equals to this. So no need to worry about this V2 minus. Now we have to find the value of this value. Okay. So what we can do? Okay, I will do find minus I1 by I1 equals to 80 millivolt by 1.737. Okay, so if we solve 80 into 10 to the minus 3, okay, by this millivolt, by this if we solve, it will come around 184 184.2567. Okay, then what we can do, 0.01 minus I1 I have already solved, so it should be nearly e to the power, okay, e to the power this ln this, okay, 1842.2567. So if we solve this one, the entire one through calculator, and doing the I1 will nearly come 1.4. Simple calculation is there. Through calculator you can find. So I1 will be 1.4. The main equation is this one. V2 minus. Okay, we have already find everything. So now I1 is known to us. I1 is known to us. The resistance is also given. So the resistance we have to find. So in our circuit, what we have to do? That R we have to find, and the current is now known to us 1.4 milliampere. Okay, clear? And this voltage is 80 millivolt. Okay, this voltage is 80 millivolt. So what we can do, R value will be simply our 80 by I1, or this one is 80 millivolt, 80 milli, so 80 into 10 to the power minus 3, and this would be 1.4 into 10 to the power minus 3, so this should be 80 by 1.4, so it will come to 7.1 ohm. So the R value will be 7.1 ohm. So this is the final answer, the value of R we have calculated. So because this value is given, this voltage is given, I1 is given, so R V equals to IR. Okay, so like that we can find the R value also, but the very first thing we have to find the ideality factor. Okay, so this is all about this question. So thank you for watching this video.